Alright guys, today we did a few examples. First one was the minimum speed we need to do in a loop-to-loop in a roller coaster. It's got a radius of 15 meters. We found the minimum speed it needs to go was 12 meters per second. We do this by looking at the free body diagram. We have normal force, we have force of gravity. We said the sum of the forces is the normal force plus the force of gravity. And then what we always do then is we take the sum of our forces, which is the net force, and set that equal to centripetal force. From there we rearrange it for the normal force, and I explained that the normal force is equal to the centripetal force minus the force of gravity. So we looked at this and we said if the speed is some minimum number so that the normal force would be 0, that would be the speed we need to find. So we did that, we did some math, we got v is equal to square root of rg, and we get that the speed is 12 meters per second. Okay, so next example, we got a car driving over a hill, radius 83 meters, so it's a really steep hill. The question was, what's the maximum speed so that the car remains on the road? So the key here is the car is on the outside of the road now. The normal force is pushing up. It's no longer going to help us keep us in circular motion. So if the speed gets too high, what will happen is the car will lose contact with the road. So we put our F net as our force of gravity, which acts down. That's the good force here. It's helping keep us in circular motion. The normal force is not. So it takes away from that good force that we had. So we set our F net equal to the centripetal force. Force of gravity is mg. Normal force is we don't really know. We rearrange for that force, and we can see that because the normal force can't be negative, if this term gets too high, that would go negative. The best case scenario, or well, the worst case scenario here is normal force goes to 0. That means we lose contact with the road. We set that, we find the speed, we get, again, the square root, it's equal to square root rg. But this time that's for the maximum speed, not the minimum like we had in the roller coaster. We get, in this case, the maximum speed is 28 meters per second. Okay, next problem is basically from your textbook, except I didn't give you any numbers. Here's the situation. We have a spinning ride. This is an overhead view. Here's a person inside. That's their overhead view. If we look at the free body diagram on that person, we have force of gravity pulling them down. We want just the force of friction against the wall there to hold them up. And the only force acting towards the center in this case can be the normal force. So there's our free body diagram. If we look at the forces in the y direction, we have the force of friction equal to the force of gravity. We set mu Fn for the force of friction, mg for the gravity. Then we reached a dead end. So then we go over to our x components. We get net force in the x direction is the normal force. Normal force then is equal to the centripetal force. Then we take that, we sub it in there. We cancel some m's from both sides. We get almost the same thing again. V is equal to the square root of rg, but now it's over mu. If we subbed in our numbers there for r, g, and mu, if I actually gave you those, you could find the minimum speed. From there, a good exercise would be to then find the minimum period of revolution and the minimum frequency of revolution, just to get practice in doing those things. Okay, this is another typical problem you guys will see. It's people in a rotating spacecraft. The question is, what speed do we need to rotate it at so that this normal force here pushing them towards the center becomes enough to give us 90% the force of gravity? So we look at this mass m right here. We draw our free body diagram over here. There's our normal force again, pushing it at this point towards the center that way. Given the radius of the spacecraft here, we can then solve for a few things. So we got a Fn is equal to our F net. Fn is then equal to the centripetal force we want the normal force to be 90% the force of gravity, so 0.9 mg is equal to mv squared over r. You solve this, you get the minimum speed is 30.7 meters per second. Then we said, okay, well, what RPM would that be? So the circumference is 2 pi r. We know that the period is distance divided by speed. So the period is 2 pi r, which is the distance they cover, divided by the speed. We get the period's 21.9 seconds. Then we went to finding, well, what is the RPMs? So the revolutions per minute. We got that it was this many seconds to revolve once. So then we roughly worked it out to, okay, that's going to be 3 revolutions per minute. Because 20 seconds goes into a minute 3 times. But then we actually solved it. We said period is equal to 1 over frequency. We found the frequency in hertz, and then we times that by 60 to get the RPMs. Alright, that's the whole lesson in 6 minutes 10 seconds. Hope you guys like that.